Hello students, welcome to Saurav's classes. Today our topic is triple integration and here a question is given. We will have to solve this question with the help of the application of triple integration. And at first let me tell you what is triple integration. Triple integration is basically the extended version of integration and double integration. It means when we use integration thrice in a sum, then it is called triple integration. So now let's solve this question. Okay, here it's given integration 0 to 1, integration 0 to root over 1 minus x square, integration 0 to root over 1 minus x square minus y square, 1 by root over 1 minus x square minus y square minus z square dz dy dx. So let's get started. That is equals to, we can say, integration 0 to 1, integration 0 to root over 1 minus x square, integration 0 to root over 1 minus x square minus y square. Now 1 by root over 1 minus x square minus y square minus z square, and here is dz, dy and dx. Now that is equals to, we can write this is ax is equals to 0, here y is equals to 0, and here we can write z is equals to 0 for the lower limits. Okay, so now in our next line we can say that integration x equals to 0 to 1, integration y is equals to 0 to root over 1 minus x square, and integration z equals to 0 to root over 1 minus x square minus y square. 1 divided by root over 1 minus x square minus y square whole square minus z square, and here we can write dz, dy and dx. We are simplifying this term. Now that is equals to, we can again write integration of x equals to 0 to 1 and integration of y equals to 0 to root over 1 minus x square, and then we can write it as sine minus 1 z by root over 1 minus x square minus y square, and we are putting these limits here. Okay, let me take a new color. So these limits we are putting here, that is root over 1 minus x square minus y square, and here is 0, the lower limit is 0, and dy dz. That means we have integrated this part, this whole part with respect to dz, and this is because integration of 1 by root over a square minus x square dx is equals to, we know that is equals to sine root over minus x by a. So that is why here we have used sine minus 1. Now from that part we can write it as, this is equals to integration x equals to 0 to 1, integration y equals to 0 to root over 1 minus x square, and sine 1 and and here is 1 minus sine -1 0, and here is dy dx. Now from this again we can rewrite it as integration x equals to 0 to 1 and y equals to 0 to root over 1 minus x square, and from that we can write here the value is pi by 2 dy dx. So this value we are writing it as pi by 2. Now this is equals to integration x equals to 0 to 1 integration y equals to 0 to root over 1 minus x square pi by 2 dy dx. Now from this we can write it again as we are taking this is pi, so we are taking this pi by 2 as constant, so we are taking it out of the integration. So pi by 2 integration x equals to 0 to 1 and y, and we are putting the value of the limits here. So this is root over 1 minus x square and here is 0, this is dx. Now we have got this after integrating this integration y equals to 0 to root over 1 minus x square pi by 2 dy. So from this part we have got this part, and now from this we can write it as pi by 2 integration 0 to 1 root over 1 minus x square dx, that is equals to pi by 2. Now we are integrating this part, that is x by 2 into root over 1 minus x square plus 1 by 2 sine to the power minus 1 x, and we are putting the limits here. Now this is because we know that integration of root over a square minus x square dx, that is equals to x by 2 root over a square minus x square plus a by 2 sine whole minus 1 x by a. Okay, now from this we can write, putting the values of the limits, we can write it as pi by 2 into 0 plus half sine 1 whole to the power minus 1 minus 0, and this is equals to pi by 2 into pi by 4, so that is equals to pi square by 8. So this is the answer.